Hi there, Mr. Sutton here with the IM3 Honors 4-2 Extra Practice Number 2 solutions on completing the square. To solve this quadratic equation, since we do not have any linear term, we can just use square rooting after we isolate that squared term. So to get this started, let's subtract 9 from both sides. That gives us 324 on the right side. And now if we divide both sides by 4 to get that x squared truly alone, well, let's see here. 324 divided by 4. Well, 320 over 4 would give us 80, so this is 81. And if x squared equals 81, now I can square root both sides. So that leaves me with x equals, now let's see here, it would be 9 normally, but since I'm square rooting an equation, I also have to put the negative root in there as well, because that would also solve this equation. So this is going to be plus or minus 9. On this problem, since I have a squared term and a constant, I can solve this by square rooting both sides, and I can do the square rooting right away since my squared term is already isolated. So square rooting the left side, we've got 4p plus 1 with no square parentheses. That was kind of the whole point of square rooting it. And then on the right side, I'm going to have 9, but since I'm square rooting an equation, it's going to be plus or minus 9. I always have to remember the negative root when I'm using square root to solve an equation. And now I still have to isolate the p, so subtract 1 from both sides. That's negative 1 plus or minus 9. And then to get p by itself, we divide by 4, so negative 1 plus or minus 9 over 4. And since we are able to combine negative 1 and 9, we have to do so and reduce it to get our two different answers. So we've got negative 1 plus 9 over 4. That's going to be 8 over 4, which is 2. And then we have negative 1 minus 9 over 4. That's going to be negative 10 over 4, which I can reduce by 2 to be negative 5 over 2. On this problem, I'm trying to solve for x. Now, since I have essentially a squared term and a constant, I can solve this one by square rooting, but first I have to isolate that squared term. All I have to do to isolate it, though, is divide both sides by negative 2. If I do that, I have x minus 3q, or squared rather, equaling negative 10. And at this point, I can go ahead and square root both sides. So if I square root the left side, I've got just x minus 3, no square. And on the right side, there's a few things going on. For one thing, I'm going to have to write plus or minus square root because I'm square rooting an equation. And also, because I have a negative that's going to end up inside that square root, on this step, I'm just going to take that out right away as an I. So I'm going to write plus or minus I radical 10. And just one more step, isolate the x by adding 3 to the other side. So that's going to be x equals 3 plus or minus I radical 10. For this problem, I'm going to solve this by completing the square. I might be able to factor this, I'm not really sure, but completing the square is just kind of a straightforward process. So let's start by subtracting that constant to get it over to the other side. And then I have to divide everything by 3 because I don't want to have my a value hanging around in front of the x squared. So that'll give me an x squared, and then we'll have 5 over 3x, and then this will equal negative 4/3. At this point, I'm ready to take half of my b value, so half of 5 over 3. Multiplying that by 1/2 gives me 5 over 6. So I'm going to add 5 over 6 squared to both sides of the equation. And that is going to complete the square on the left side. That means that I can now factor my left side into x plus 5 over 6, whole thing squared. On the right side, I'm going to clean this up a little bit now. 5 over 6 squared, that's really 25 over 36. And I still need to combine that with the negative 4/3. Negative 4/3 is how many 36? Well, if I multiply by 12 over 12, that's going to be negative 48 over 36. And then negative 48 over 36 plus 25 over 36, that's negative 23 over 36. So a lot of fraction math going on over there, but I've got it cleaned up. Now I've got one thing on the right side and a perfect square on the left, so I'm ready to go ahead and square root both sides. Square rooting both sides of my equation gives me just x plus 5 over 6 on the left side, and on the right side, the square root of all this stuff, square root of negative 23, I can write that as I radical 23. Square root of 36 is just 6. So I have x plus 5 over 6 equaling plus or minus, don't forget the plus or minus, I radical 23 over 6. I'm almost done. I still need to isolate x though. I do that by subtracting 5 over 6 to the other side. Now since we have a common denominator of 6, I can actually put the minus 5 over here in one big numerator with the plus or minus I radical 23. And that'll give us a denominator of just a single 6 down here. So I just subtracted 5 over 6, combined like fractions on the right side there. And this is as good as it's going to get. Can't really simplify anything else. For this problem, half the battle is just kind of figuring out what they're really asking for. So they're saying f is the greater, or at least more positive, of the two roots of equation 1. So equation 1 has two answers. We want the bigger one of those. And then g is the lesser or smaller of the two roots of equation 2. So we want to take this f root and this g root, which we still need to find, and eventually we want to multiply them together, the product f times g. But before we can do that, again, we have to find those possible roots. So we're going to solve each of these equations for x. Now for this first equation, this might be factorable, but since we've already got this 4 cleared out to the other side, we might as well go ahead and complete the square on this one. So I can start that by dividing everything by the a value, the number next to the x squared. That'll give me just x squared plus, now dividing everything by 2, we've got 7 halves x equals 4 divided by 2 is 2. Next, I'm going to complete the square on the left side. So I need half of my b term, half of 7 halves. Let's see, if I multiply that by 1/2, that's going to be 7/4. So it's really 7/4 that I'm squaring and adding to both sides here, plus 7/4 squared on each side. Next, since I've completed the square on the left side, I can factor this into x plus 7/4 whole thing squared. And on the right side, I'll just start simplifying things. So 7 over 4 squared, that's really 49 over 16 if I square both of those. And I'll have to clean this up a little bit more. Common denominator here, I've got 2 over 1 initially. I can make that, if I multiply by 16 over 16, I can make that 32 over 16. And then if I add those together, 32 plus 49 is 81 over 16. At this point, since I've got a square and just one thing on the right side, I'm good to go ahead and square root both sides. So that leaves me with x plus 7/4 on the left side. And on the right side, square rooting, let's see here, square root of 81 is 9, square root of 16 is 4. So we've got plus or minus 9 over 4 over on that right side. Now I can go ahead and subtract the 7/4 to get x totally by itself. And this is going to give me two different answers. I can combine these, and I'm going to have to if I want to get just one number for this f value that we were looking for. So we have negative 7 plus 9 over 4. That's 2 over 4, which I can reduce to 1/2. We also have negative 7 minus 9 over 4. That's negative 16 over 4, which we can reduce to negative 4. So those are our two possible values for f. And they said they wanted the greater of those. So just moving forward, we're going to take 1/2 because that's bigger, that's more positive than negative 4. But we still have to solve this other equation to get the g value. This one's a little bit quicker to solve. We already have a perfect square and a number, so we can square root things right off the bat here. I mean, you could expand this, move the 9 over, and then factor it, but that's just kind of taking the long way around, and it might not even be factorable. Who knows? So let's go ahead and square root. We'll have y minus 1 equaling plus or minus 3. Just square rooted both sides. And then I'll add this 1 to get that over to the other side. Next, I can combine these a little bit here. We have 1 plus 3, which is 4, and 1 minus 3 giving us the other possible y value of negative 2. So again, I wanted f times g when all is said and done. F is the bigger number between 1/2 and negative 4, so that's 1/2 because that's further to the right on the number line. And they said g is the lesser of the two roots for the second equation here. So negative 2 is less than 4, so we use negative 2 for the g value. Multiplying those together, 1/2 times negative 2, that's just negative 1, which finally, at the end of this journey, gives us answer choice B.